So in this video we are going to discuss a special type of substitution that is used in integration by substitution, and the name of this substitution is Weierstrass substitution. This particular substitution is very important for doing one specific form of integration that is taught in CBSE class 12 and ISC class 12 and JEE means curriculum. So the type of the form of the integration is like this. So integration dx divided by 4 plus 5 cos x. We have to remember this pattern of this integration, where in the numerator there is 1 and in the denominator we have 4 plus 5 cos x. Sometimes it is 5 plus 4 sin x, or sometimes it is 1 minus 2 sin x, or sometimes it's 3 cos x plus 5 sin x. Whatever trigonometrical ratio we have in the denominator we always have 1. So this is the type of integration which we have to do using Weierstrass substitution. So before we move on to the substitution part, we have to remember some submultiple formula that we have, trigonometrical submultiple formula that we have done in class 11. So one is sin x is 2 tan x by 2 divided by 1 plus tan square x by 2. This is one form. Then we have tan x equals to 2 tan x by 2 divided by 1 minus tan square x by 2. Okay, then we have cos x equals to 1 minus tan square x by 2 by 1 plus tan square x by 2. These are the three trigonometrical submultiple formulas that we have to remember for proceeding with Weierstrass substitution. So whenever we have a integration of this form, what Weierstrass substitution states is that we have to take let tan x by 2 equals to z. Yes, we have to take let tan x by 2 equals to z. Now we know that in integration, whenever we take something as z, we have to differentiate. So derivative of tan mx is m sec square mx dx equals to dz. Okay, now what is dx? So dx is 2 dz divided by sec square x by 2. That is nothing but 2 dz divided by, now we know that there is a formula in trigonometry, sec square x by 2 minus tan square x by 2 equals to 1. So sec square x by 2 is 1 plus tan square x by 2, that is equals to 2 dz divided by 1 plus, so tan x by 2 is z, so that gives me 1 plus z square. So dx equals to 2 dz by 1 plus z square. Now what we are going to do, we are going to substitute this value in this integration. So that we are going to get as integration dx divided by 4 plus, now what can we write on cos x? We have to write on cos x in terms of tan x by 2. So that is 1 minus tan square x by 2 by 1 plus tan square x by 2. Now we can just go ahead and put our substitution. So we can see that dx is 2 dz by 1 plus z square. So 2 dz by 1 plus z square whole divided by 4 plus 5 into 1 minus, in place of tan x by 2 I can put z, so that is z square by 1 plus z square. Okay, that is going to become 2 dz by 1 plus z square whole divided by 4 into 1 plus z square plus 5 1 minus z square divided by 1 plus z square. This 2 gets cancelled out. Now see, the integration slowly starts taking an easy form. So integration 2 dz whole divided by 4 to 4z square plus 5 into 5z square, that is 2 dz 2 dz 9 minus z square. So now what we can do is that we can take minus common, 2 dz divided by z square minus 9. We can also keep minus 2 common outside, dz by z square minus 3 square. Now this particular integration follows a particular form, which is integration divided by z square minus a square form. So we have a formula, okay, this is the formula, that is integration dx by x square minus a square is nothing but 1 by 2a log mod of x minus a by x plus a. Okay, so we are going to apply that same formula over here. So minus 2 will remain outside into 1 by 2 into a, here a is 3, log mod of z minus 3 by z plus 3. So 2 gets cancelled out, minus 1 by 3 log, what is z, what we took as z, we took tan x by 2 as z. So tan x by 2 minus 3 divided by tan x by 2 plus 3. Now just since this minus is over here, we can actually reciprocal the log, and so that we can manage this minus. So log tan x by 2 plus 3 divided by tan x by 2 minus 3, and then plus c. This is the final answer of this integration. Let's go back and revise it once again. Integration dx by 4 plus 5x. So whenever we have an integration of this form, where there is nothing in the numerator, but in the denominator we have a trigonometry like cos x or sin x, we should move ahead with Weierstrass substitution. Weierstrass substitution has been discovered specifically for integration of this type. So what we take tan x by 2 as z, and then we differentiate, as usual we do in integration. Whenever we take something as z, we have to differentiate both the sides. So we're differentiating, and then we're getting dx as 2 dz divided by sec square x by 2, that is 2 dz by, now what is sec square x by 2, sec square x by 2 minus tan square x by 2 is equals to 1. So sec square x by 2 is 1 plus tan square x by 2, so that is 1 plus tan square x by 2, that is 2 dz divided by 1 plus, now what is tan x by 2, tan x by 2 is z, so that is 1 plus z square. Now we have a different trigonometrical formula, submultiple formula. Sin x is 2 tan x by 2 by 1 plus tan square x by 2, tan x equals to 2 tan x by 2 by 1 minus tan square x by 2, and cos x is 1 minus tan square x by 2 by 1 plus tan square x by 2. So here we are going to use this formula, this one, because we have cos x in our integration. If sometimes we have tan x in our integration, we have to use this formula. If we have sin x in our integration, we have to use this formula. So since we have cos x over here, we are going to use this formula. Now we are substituting the value, integration dx divided by 4 plus 5 into, okay, so cos x is 1 minus tan square x by 2 by 1 plus tan square x by 2. Okay, now tan x by 2 is written as z. So what we are getting, and dx is substituted as this value, 2 dz by 1 plus z square. So dx, in place of dx we are putting 2 dz by 1 plus z square whole divided by 4 plus 5 into, in place of tan x by 2 we are putting z, so which is becoming z square. Again in place of tan x by 2 we are putting z, so it is becoming z square. Now a little bit of simplification, what is happening, 1 plus z square is getting cancelled out, okay, and then we are getting 9 minus z square over here, taking minus common, integration 2 by z square minus 9, taking minus 2 common, we are getting integration dz by z square minus 3 square. Now we have a formula, this formula we have integration dx by x square minus s square is 1 by 2 log mod of x minus a by x plus a. So we are comparing this formula with this. So that is minus 2 into 1 by 2a. What is a over here? 3. Log mod of x minus a. So here it is z. Z minus 3 by z plus 3. 2 gets cancelled out. We are getting minus 1 by 3 log mod of. Now what is z? What is z over here? Z is, we have tan x by 2. So therefore tan x by 2 minus 3 by tan x by 2 plus 3. Okay. Because this minus, I'm bringing this minus on top of the power of log. Okay, so what is happening, the denominator is going down and the numerator is coming down. 1 by 3 into log tan x by 2 plus 3 by tan x by 2 minus 3.